Prince Sagai Sudarshan, Associate Professor, Department of Mechanical Engineering, Rogni College of Engineering and Technology. So today we are going to discuss about cutting tool materials, tool wear and tool layup. It belongs from the Manufacturing Technology, Unit number 1 for the 4th semester Mechanical Engineering students. Cutting tool. If coolant is used in cutting, the heat drawn away by the chip can be as big as 90% of the total heat dissipated. Knowledge of the cutting temperature is important because it affects of the wear of the cutting tool. Cutting temperature is the primary factor affecting the cutting tool. Wear can include thermal damage to the machine surface. High surface temperature promote the process of oxidation of the machine surface. The oxidation layer has worse mechanical properties than the base material, which may result in the shorter service life. Causes dimensional error in the machine surface. The cutting tool elongated as result of increased temperature and the position of the cutting tool edge shifts toward the machined surface, resulting the dimensional error of about 0.01 approximately 0.02 mm. Since the processes of thermal generation, dissipation of solid body, thermal deformation are all transit, sometimes is required to achieve a steady state condition. Cutting temperature determination. Cutting temperature is either measured in the real machining process or predict in the machining process design. The mean temperature along the tool face is measured directly by means of different thermocouple techniques or indirectly by measuring the infrared radiation or examination of change in the tool material, microstructure or micro hardness induced by the temperature. Some recent indirect methods are based on the examination for temper cooler of a chip and the use of thermosensitive pints. There are no simple, reliable methods of measuring the temperature field. Therefore, predictive approaches must be relied on the obtain the mean cutting temperature and temperature field in tool and workpiece. For cutting temperature prediction, analytical methods, numerical methods. So first of all, we are going to discuss about the analytical methods. There are several analytical methods to predict the mean temperature. Interested readers are encouraged to read more specific texts which present in detail these methods. Due to complexation of the metal cutting process, the analytical methods are typically restricted to the case of orthogonal cutting. Numerical methods. These methods are usually based on the finite element modeling of metal cutting. The numerical methods even through more complex than the analytical approaches allow for production not only the mean cutting temperature along the tool face but also the temperature field of orthogonal and oblique cutting methods. Cutting tool materials. So cutting tool materials also record some basic needs. The cutting tool material must possess the number of important properties to avoid excessive water, fracture, failure, and high temperature in cutting. The following characteristics are essential for cutting material to withstand the heavy condition of the cutting process and to produce high quality and economical parts. Hardness at evaluated temperature, so that hardness and strength of the tool edge are maintained in high cutting temperature. Toughness, the ability of the material to absorb energy without falling, cutting off on. So accomplished by impact forces especially if cutting is interpreted and cutting tool may fail very soon if it is not strong enough. Water resistance, although there is a strong correlation between the hot corners and wear, resistance later depends on more than just hardness. Other important characteristics include surface finish on the tool, chemical hindrance of the tool material, so work material and thermal conductivity of the material, which affect the maximum value of the cutting temperature of tool chip interface. Cutting tool materials, carbon steels. If the oldest tool material is carbon steel, the carbon content is 0.6 percentage to 1.5 percentage, with small quantities of silicon, chromium, manganese, and vanadium to refine grain size. Maximum hardness of the HRC is 62. This material has low wear resistance and low hardness. The use of this material now is very limited. High speed steel HSS was produced in 1990s. They are highly allowed with vanadium, cobalt, molybdenum, tungsten, and chromium added to increase hot and hardness and wear resistance. Can be hardened to various depth by approximately heat treating up to cold hardness in the range of HRC 63 to 65. The cobalt component give the material a hardness value much greater than the carbon steels. The high toughness of good wear resistance make HSS suitable for all type of cutting tools, which complex shapes for relatively low to medium cutting speeds. The most widely used tool material today for taps, drills, reams, gear tools, and cutters, slotting broaches. Cementite carbides introduced in 1930. These are the most important tool materials today. High hot hardness and wear resistance. Having the main disadvantage of the cementite carbide is their low toughness. These materials are produced by powder metallurgy methods, sintering grains of tungsten carbide in a cobalt matrix. There may be other carbide in other mixer such as titanium carbide or titanium carbide addition of WCU. So ceramics material are composed primarily of fine grained high purity aluminum oxide Al2O3 presented and sintering with no binder. Two types are available: white or cold pressed ceramic, which consists of only Al203 cold pressed into the instead of and sintering at high temperature. Cubic boron nitrate, CBN, and synthetic diamonds. Diamond is the hardness substance ever known is all material. It is used as a coating material. In it is polycrystalline from as a single crystalline diamond tool for a special application such as mirror finishing of non-ferrous material. Next to diamond, CBN is a hardened tool material. CBN is used mainly coated material because it is very brittle. In spite of diamond, CBN is suitable for cutting ferrous materials. Tool life and tool wear. The life of the cutting tool can be terminated by the number of means, although they are broadly into main two categories. Gradual wearing of certain region of the face and flank of the cutting tool and tool failure consists of the more desirable case of OE life of the cutting tool. Therefore, it is determined by the amount of wear that the occurred on the tool profile and which reduce the efficiency. The replace of the tool, which is a new one, the second possibility applies in the two cases when the resource of the tool reshaping is exhausted. To life, the life of the cutting tool can be terminated by the number of means, although they are fall broadly into main categories already we discussed. Although the wear curve is known as for blank wear in similar relationship occurs for the wear type. It is defined the tool life for a wear creation parameter which is affect the rate of tool wear, cutting condition, cutting tool geometry, properties of the work material, surface finish. The machining process generate a wide variety of suitable structures. Surface structure consists of the repeat and random deviation from the ideal smooth surface. These are surface, surface, waviness, lay, bearing properties of perfectly smooth surface is not good bearing because cannot maintain the lubricating film. So some factors against the surface finish. So we should follow the surface finish parameter so we can able to generate the good surface product. Cutting fluids. Cutting fluid is any liquid or gas that is applied to the chip and the cutting tool to improve the cutting performance. So methods of application of the manual application. Application of the fluid from the can automatically by the operator. It is applicable for even the job shop. Suitable for except the tapping and some other observations where cutting speeds are very low. Coolant feed tooling. Some tools, especially drills and deep drills, are provided with axial holes through the body of the tool of the cutting fluid can be pumped directly the tool cutting edge. Suitable oils. The most common cheap and features from the cutting fluids consist of the droplets. The typical ratio water and oil is 30:1. Machinability is the term including the how the work material represent in the cutting process. In the most general case, good machinability means that material is cut with good surface finish. Selection of cutting conditions. These are the selection of cutting conditions. So these are the basic metal cutting tool and tool lives. Thank you.